Hello everybody, welcome to Marketing Analytics course. This is week 2 session 5 and this is Dr. Shagata Chatterjee, Vinod Gupta School of Management, IIT Kharagpur, who will be taking this course. So, we are discussing about what consumers want and we will continue on that discussion in this particular video as well. Till the last session we have discussed about conjoint analysis a little bit, and here in this particular video we will actually set up the premise for choice based conjoint. So, before we do anything on choice based conjoint, we have to do a little bit of something called choice modeling. So, what is choice modeling? Choice modeling is actually trying to empirically see or trying to create a econometric or I would say quantitative model to actually find out how customers make choice. And here in this particular video, we are focusing on choice which is yes no kind of choice. So, whether you will buy something or we will not buy something. So, it is a binomial choice, but there can be multinomial choices as well, which we are keeping it aside right now. So, multinomial choices is something like that, where you have multiple choices in your hand. So, choice A versus choice B versus choice C, choice D, and you try to choose that which one out of this which one out of this 4 will you choose. So, here in this particular one we are focusing on binomial choice. So, I have a data set where we are majorly focusing on mobile number porting. So, the data set is about mobile number porting. So, we have to understand what is mobile number porting. So, this is something that has happened in India probably around 7-8 years back. When the mobile number porting facility was brought in, that means you can keep your same mobile number, but you can switch from one service provider to another service provider, keeping the mobile number same. So, the generic procedure of this mobile number porting is like this, that you send a request to your service provider about that you want to port, and the service provider is mandatorily have to give you a porting code, and with that porting code you have to go to the next new service provider, give that porting code, and within some days that particular number gets transferred. But there are certain problems in that. There are certain issues that creates that probably sometimes hinders you from going from one service provider to another service provider. So, mobile number service providers always what they do is, the moment you actually try to do porting, you have sent the request. More specifically, if you are a very profitable customer or you are probably a customer who is postpaid customer. So, they think that postpaid is more profitable, and probably that is true as well. So, if you are a postpaid customer, they will call you and they will ask you, okay, what happened sir, why are you why do you want to switch from service provider 1 to service provider somebody else, and what kind of facilities I can give you, is there a service problem, because we can improve the service problem, and so on. And then they will also say that, okay, so there are new offers that are coming up, you can get some discounts in the next billing and etc. So, they will give you lots of offerings to make sure that you stay back. So, that is something that they do. But when you still say that, okay, I will not go into all these details and etc., they will send you a survey. Probably sometimes they send you a survey, or sometimes through that vocal voice based conversation, they take a survey to and ask you that what is the service quality perception, price perception, blah blah blah, and you give ratings on that. So, now this is something is like exit interview in case of HR problem. So, it is like when somebody is leaving the service provider, why he is leaving. So, when you get this data, you can analyze this data to find out that what are the things that customers who are switchers or customers who are non-switchers think that is important. So, what customers value when they are switching. In this context, I want to talk about 4 switching barriers. So, this is marketing concept, where we say that you can also set up certain kind of switching barriers to make sure that your customer does not go away from you. So, what are the various switching barriers possible? One is economic switching barrier. Economic switching barrier is related to this. For example, in this same context, if I talk about, let us say, mobile number porting, the moment you try to port from one mobile service provider to another service provider, all the balance that you have in your SIM card goes actually gets nullified and you do not get that facilities. It is possible that the same thing is applicable for other cases also, where let us say you have a let us say 6 months or 1 year contract or something like that, and you are getting some benefits because of those contracts, and now you are leaving the service provider and going to some other service provider. All of your contracts benefit, whatever you used to get, will go off. So, that is a very basic problem that which will probably sometimes stop you from switching. So, which is called economic switching barrier. Now, another is let us say social and psychological switching barrier. This happens in mobile phones quite commonly, that I have all my people in the same network, which is let us say XYZ. So, then why will I switch from XYZ to somebody else? So, that becomes a very major problem, and that is something called social and psychological. So, I am habituated with this mobile service provider, I do not want to switch from here to somebody else. And then comes procedural switching barrier. Procedural switching barrier is about how difficult is the procedure. For example, let us say if you have to take lots of I would say permissions from here and there to switch from one place to another place in terms of service provider. If there were mobile number code, then you go and give it to the new mobile number service provider, and then they give some code, and then you have to again go back to the old one and give that number to that old one, and there is lots of paperwork in between and blah blah blah. Then all of these things is a procedural problem, and if there is a huge procedural switching barrier, you might not want to switch. So, that is something sometimes you can create as a customer, that there is a procedural problem. So, there are obviously agencies which will take into account that how I can reduce this procedural problems, so that customers gets benefited, but oftentimes marketers do that. And then the fourth one is option related. So, whether multiple options are available or not. So, if you want to switch, options should be available. If this guy is the only possible option or number of options are less, then that creates a switching barriers, because people cannot switch. So, given that as a background, I have a data set which is called switching.csv file, which looks like this, and this is a switching data set where I have let us say the gender of the person, I have the age of the person who wanted to switch. These are all the people who actually wanted to switch, they expressed their intention to switch, and then their profession, whether they are urban or rural, what is the recipient. So, from when they switch, so we also ask that which service provider you want to go to. So, what is the recipient service provider, and then ultimately these are certain attribute wise rating. So, I will focus on this SINT is actually switching intention, and these are other things like service quality. The first one is ServQual, that means service quality. Next one is satisfaction, and then 3 switching barriers: PSB, ESB and OSB. PSB is procedural, ESB is economic, and OSB is operational. So, operational will include both option related and social psychological. So, together this and this together we have created the OSB. So, that is there, and then there is a price component. Price means price perception. So, if whether the price is good or bad in comparison to the other service providers. So, we think that all of these values will impact your switching behavior, and that might change over the effect of this from column number I to column number N on column number H might differ if you are an employee or rural or based on the recipients and etc. So, this is something that we will try to study, that what matters, whether the switching barriers matters, whether the switching barriers matter, then which switching barrier will matter, and then whether satisfaction matters or service quality matter or price matter, what people actually value. So, here you see the difference between the previous examples and this example is your Y variable, which is the SWBA, switching behavior, that means ultimately you switched or not, is a 1-0 variable. 1 means you switched and 0 means you did not switch or something like that. Actually 1 means you stayed back and 0 or 1, so we will see that, So, to do that, what I will do is there is a switching behavior.r file, I will open that as usual and then set working directory to source file location and then read the data. So, my data set is more or less simplified. So, strdf will give me that okay, my swbh is an integer function. So, this is my y variable and subcoil to price is my x variable, all are numeric. So, I do not have any problem right now, and I will add certain covariates as well. Covariates means certain control variables, the variables which I will include. I am not focusing on them, I will not focus on their behavior. So, covariates is like this. So, let us say I am trying to find out the impact of x1, x2, x3 on y, some y, but there is another guys. So, let us say x4 and x5, historically they were there, they have impact. People have said that these guys also have impact, but I am not focusing on them. My research is not focusing on them, but they should also be there because historically they have been considered as a predictor of y. So, x4 and x5 should also be there. I just take them as covariates. So, I just put them in the regression. So, these are covariates, I do not focus on them much, I focus on these guys much, but I also take the other two guys in the model. So, here you will see that I have write GLM, GLM stands for generalized linear model, and here family is equal to binomial logit. So, I am doing a logistic regression. The only thing changes from linear regression to logistic regression is instead of LM you write GLM, and here one more parameter you add, that is all. The other things is same. So, whether you run logistic regression or linear regression, it is LM y tilde x1 plus x2 plus x3 comma data is equal to the data set name. So, in this case df, and then if there is it is a binomial regression, then this becomes g, and then you add another thing here, that is all. So, otherwise it is similar to linear regression, the code is similar. So, I just run that, and here age, gender, MF is for gender, profession and urban rural and recipient operator, all of these things is my basically the predictor. So, here my objective is to find relationships. So, there are two different objectives when we deal with 1-0 variable. I can do two different stuff and we have to focus on that as well. So, I can do find relationships or I can do prediction. So, there are two jobs that I can do. So, when I am trying to find out relationship between x1, x2, x3 and y, I will include whole data and I will try to find out the relationship. So, that is what I am doing. I am using the whole data, it is equal to df, and I run this and I get certain results. So, the result is given here. So, I will once more I will just plot the result is given here. So, the same result I just copied and pasted it here, and I want to understand what this means. So, in this particular thing I am seeing that, see, age is significant. Age is significant means that and age is significant and positive. That means, as age increases, your chances of staying back increases. So, 1 means staying back here. I will just see first 1 minute. So, 1 means actually living here. In this particular case, that we can see that as age increases, people are more prone towards living and changing. So, which we have to explain theoretically, we will see how we can explain. Now, what I can see in terms of satisfaction, as satisfaction increases, the switching probability decreases, minus 0.77 obvious. As service quality increases, switching probability also decreases. So, this is also obvious. But in comparison to satisfaction, service quality has more impact. And then another thing, out of this procedural, economic and OSB, the most important thing that comes up is OSB, that is operational. If you remember, operational is social psychological plus options. So, operational switching barrier will reduce the switching probability. So, if there are lots of switching barrier, you will not switch. So, that is something that is only significant, the other two PSB and ESB is not coming significant. So, I mean to say that if you want to make sure that the people should stay back in your this thing in your service provider's case, and remember the data set is only those people who have shown interest to switch. So, they have shown the interest, they all have switching intention, but ultimately they did not switch, or switch is something that we are focusing on. So, all of these guys has switching intention, means that they have already thought about procedural problems, they will already thought about economic problems. After considering that, assuming that they are informed customers, after considering that they have shown interest or expressed their intention to switch by asking for the porting number. Now, after that if you want to stop them, you cannot give economic benefit, because they already know that you will give economic benefit, and they you will not create more procedural problems, because it is something that is governed by an agency, a government agency, who will actually come and sue you in that case. But the only thing that matters in this particular context for a customer, for a company, is then that you have to create operational switching barrier, which is related to the psychology of the person, the social psychology, social and psychological issues, and options. So, you have to make sure that your option is better than others, or the availability of options is something that you can create. Now, sometimes availability of options is not also in your hand. Then what is in your hand? You have to make sure that the network of that particular person is also in your network. Actually, the human beings who are connected with this particular person is also in your network. That means his families and friends, and let us say business colleagues and etc. If they are also in your network, then the chance that this guy will switch from your network to somebody else's network, some other service provider, is very low. So, that is something that comes up here very strongly, that OSB is what matters rather than procedural switching barrier or economic switching barrier. Now, price is coming positive with this is actually the higher the price. So, as the price perception increases, that means if I think that your price is much higher than others, then I will switch. Now, you see that is 2.38, which is much higher than many other factors. So, that means one of the most important factor is price. So, obviously, service quality, satisfaction, etc., is related obviously, but persons who are trying to switch, who have shown interest in switching, price is also a very important component. So, mobile number porting does not only happen at some point when it used to happen. It is not only happen because of your quality of the service and etc., because we generally now know that most of the guys will have same level of service, somewhere it is better, somewhere it is worse, and so on. But price is something that is very important. So, you have to play the price. Now, this might be a different situation in a different context, probably in some other service situation price might not be an issue that much, but in this case we are finding that this is what we are trying to find out. Now, you have to also understand that this equation that you are getting, and all these guys which you are getting here which are insignificant, you can consider all of them things to 0. So, you can just drop profession from your model, or probably the recipient operator, urban, rural, all of these things you can drop from your model. But you have to also understand what they mean. So, for example, here this recipient operator is coming, Videocon is coming significant. So, that has some meaning, you have to actually understand that. So, I will give you a little bit of theoretical understanding of what this result is saying to me. So, this result is actually trying to predict where P is probability of switching let us say, then it is trying to predict basically ln P by 1 minus P as beta 0 plus beta 1 x 1 plus beta 2 x 2 and so on. So, that is simple logistic regression if you have an idea about that. So, that is something that I am trying to predict. So, that means that keeping everything else same, if I increase let us say price by 1 unit, then what will change? The probability of delta ln P by 1 minus P, this will change by 2.3, if I am not wrong, 2.38 or 39 into delta price. So, if price increases by 1 unit, this is the guy who increases by 1 unit, and then the probability how much it increases, you have to calculate that. If this increases by 1 unit, then p by 1 minus p increases by e to the power 1, that much unit. Then what is the formula for p, how much p increases, what was the p before and what was the p now, is something that you have to understand. So this is not actually correct. So this is like delta of ln p minus 1 by p is something that is E, not exactly this. So we have to check that. So delta of ln p minus p means ln, so this is not correct actually, sorry. So ln p by 1 minus p previous minus ln p into 1 minus p now, that is 1, and now we have to solve what is the value is coming up. So this is something that we have to take into account. So this is not a linear regression, this is a logistic regression, and the formula is like that. The formula is in a logistic function. So that we will have to consider. Now we have to also consider what is the dummy variable. So what this categorical variable mean? So by chance, if let us say if urban rural is coming insignificant here, by chance if that was significant, what would have been the meaning? The meaning is that whatever is my y is equal to let us say ln p by 1 minus p, whatever is that is actually something beta 0 plus beta 1 x 1 plus beta 2 x 2 plus basically minus 0.71 into urban, minus 0.71 into urban. I am just assuming that all other things are remaining constant. That means, if all other things remains constant, that means that let us say x 1, x 2, x 3 everything is same, and then there is a urban guy, versus x 1, x 2, x 3 everything same, then there is a rural guy. So for the first guy, the y will be some value a, let us say a is the summation of all of these things a minus 0.71, and the second guy y will be a, because he is not urban, this part will not happen. So the difference between the urban and rural is 0.71, and urban guys here less proponent towards switching. So their propensity towards switching is less than the rural guys. So that is something that we are getting here, if by chance that minus 0.71 was significant. Similarly, if there are more than one categories here, in this particular case there let us say there is urban, semi-urban and rural. By chance let us say in the result I have got urban, semi-urban and rural, and urban, so rural was the reference point which got removed, and urban and semi-urban both were significant, and this value was 0.71 and this value was 0.34. So the model would have come urban and semi-urban. So I would say then that y is equal to basically a, keeping everything else same, a minus 0.71 into urban minus 0.34 into semi-urban. That is what you would have got in the regression equation. So y is actually what? Ln of p by 1 minus p. And what is a? A is actually beta 0 plus beta 1 x 1 plus beta 2 x 2 and so on. Now if I have 3 persons, let us say person number 1, person number 2, person number 3, person number 1 everything is same, but it is urban guy, person number 2 is semi-urban guy, person number 3 is rural guy. So y1 will be a minus 0.71, y2 will be a minus 0.34 and y3 will be just a, because this guy is neither this is 1 nor this is 1, neither this is 1 nor this is 1 for y3. So if that is the case, then I can say that okay, y2 who is a semi-urban guy is 0.34 less propensity of going for a switching. So log odds are 0.34 less, and in first case log odds are 0.71 less. By chance, if I have taken SU as the factor, SU as the reference point, then the whole equation would have changed in a different way. Here in this particular equation, rural was the factor which was the which was the reference point. By chance in the regression, if you have got or you want to know that how a guy is has more propensity of switching in comparison to the semi-urban guys. So, semi-urban guys becomes your reference point. In that case, the function will be y is equal to a minus. Now, remember y3 is 0.34 less than SU. So, this will be just pass 0.34 into rural. And what is the difference between SU and U, that means semi-urban and urban? This guy is minus 0.71, this guy is minus 0.34. So, another 0.37 less. So, minus 0.37 into urban. So, then if you just consider that, then the difference between urban and semi-urban and rural is still as it is, as it was in this case. So, this is something that you have to understand, that I can find out for any variable, I can find out the corresponding, I would say the corresponding levels, how they are different. Now, this is for explaining purpose. Now, I can do predictions as well. So, prediction is something that we do also in this particular modeling. Prediction is something where I actually, so it is like how you go and talk with a fortune teller. Let us say any kind of fortune teller. If you go to a fortune teller and if you want to know that whether the fortune teller is good enough or not, you try to say that okay, why don't you actually, so I will give you some information, and why don't you actually tell me about my few past which has already happened. I will not disclose the past to you, and you should tell me a little bit about my past. If you can explain it properly, then I will say that okay, you are good enough. If you cannot explain it properly, then I would say that okay, I do not think you are good enough and I should go ahead and do something else. So, that is something that I would also want to do in this particular case. So, let us say, so fortune teller, what do you do? So, you have a past data, you from that past data you break it, you say that this part of the data is something that I will give to fortune teller. So, this is your, and fortune teller has his own model, every fortune teller will have his own model, own way of creating a model. So, this is some part of the data and this is the data that you do not disclose. So, this is called training data and this is called test data. This part is something that you do not disclose, this you do not disclose and this you disclose. And then based on this training data he creates the model, some model. Now, in that model then he comes up with the model and applies in the testing data a little bit and create a prediction. So, let us say he asks your date of birth, age of birth, sometimes some people actually ask you to see in a cup, or some people ask you to pick up a card, all of that is training data. That is something based on which you will create the model, and based on that creating the model he gives some prediction. So, he sees your behavior and etc., and he also creates a model, together he gives a prediction. So, that prediction you actually go and check with the actual values, and if the actual value and the prediction value are close to each other, then you are happy. If it is not so close to each other, then you are unhappy. So, how close it is, based on that you decide that which fortune teller is better, which fortune teller is worse. So, here how he has created the model, using what kind of methodology, we generally do not know. So, that is why we generally do not focus. In this particular case, in our case, the only thing that is different from that fortune teller's case and our case is probably we have to say that how this model is created. We have to actually talk about that also. So, I will do something like that here in my data set. So, I am creating objectivist prediction. So, what I create is, the first thing that I create is the training data and testing data. So, I create a sample of, so dim df1, what is dim df1? Just check. Dim of df is actually dimension of df, dimension of my data set. Dim df1 is nothing but the number of rows, because see there are 400 rows and 15 observations. So, that is coming in the dimension of df. The first entry of that is just the number of rows. So, out of 400 rows, so out of 1 to 409, so if I just write this, this will come like this 1 to 409. Out of 1 to 409, I am choosing 120 guys randomly I am choosing. So, I am choosing this run and I am getting here 120 observations which are some numbers between 1 to 409. Those numbers, those 120 I am taking. So, I am breaking it in 70%, 30%. 70% are my training data, 30% is my testing data. 30% of 409 is around 120. So, that is why I am taking 120. These 120 guys creates my testing data. So, randomly selected 120 rows and anything other than this 120 rows creates my training data. So, I just create that. And then keeping everything same, I create the model on my training data. And as usual, the model is coming, there are various variables which are coming significant, there are some more variables which are coming not significant. To improve the model, we use something called a step function. Step function is stepwise regression, one at a time it will go on dropping based on the goodness of fit, it will start dropping the insignificant variable and after doing that it will only show me the best model possible. So, this is the best model that is possible. See, recipient operator has not been dropped because some of the recipient operators are coming significant. So, you cannot drop. So, this is the best model based on this AIC value. So, goodness of fit value I am getting the best model currently. So, I will not see the model, how the model looks like. My job is not seeing that right now when I am doing prediction. When I am doing explanation, I will do all of these things. But when I am doing prediction, my job is to do prediction only. So, now with this model, I told you what in this thing that with my model and with my test data, I create predictions. So, the same thing I will do it here. So, predict R3 is the model name and new data is testing data and type is equal to response means I am asking them that this is, so treat y as response, that means y as a probability, you give me the probability rather than the exact value. That means, you give me the log of p by 1 minus p, solve that p and give me the value. So, that is the predictions. So, if you new data is equal to just 1 minute. So, error in model frame, recipient operator has new levels. Okay, so, here by chance the recipient operator had new levels. So, I will run this once more. I will quickly run this part once more. Yeah, so I got it. So, it is better to set sheet to actually solve this problem. Anyway, so I got it and then I want to predict. So, here I am saying that my cutoff will be the switching behaviors mean. How many people are switching? So, classically many people take 0.5. So, I will just change it to 0.5 for currently, take 0.5 as the cutoff. So, anything lower than 0.5 probability is 0, anything higher than 0.5 probability is 1. What I did previously was taking the mean propensity. What is the mean propensity of switching? Or not always probability. So, let us say if the mean propensity is very low, only 30% guys are switching, then I will take that mean propensity as my cutoff. So, that is what let us say that is what I do. I take the mean propensity of switching as my cutoff. Anything lower than that probability is 0, anything higher than that probability is 1 and then actual is obviously the switching behavior and I create a table. Simply I create a table. Here I see that this is the confusion matrix. What is this confusion matrix? The columns are 0, 1 which is the actual 0 and actual 1 and this is my predicted 0 and predicted 1 and out of actual zeros I am predicting 61 right out of 70. So, 61 plus 9 there were 70 actual cases where people did not switch and 50 actual cases. So, if you just do the column sum, 50 actual cases where there was switching and 70 actual cases there was not switching. Out of those guys who are switching, I am correctly predicting everybody, but out of those guys who are not switching, I am correctly predicting 61 and this is the error. This is one error, this is one error. So, overall how much I am correct? Overall accuracy is 60 plus 50 divided by 120. This is my overall accuracy 92.5% based on this particular data set. So, this is how you can do prediction of switching behavior or non-switching behavior. So, I have shown you the basic choice modeling of how people switch, how people do not switch, and we have used logistic regression for that. There are lots of other methods that you can use to improve the model, other machine learning methods that I will not go into that, but this is whatever machine learning method you use, the procedure will be same. And to explain, for explaining purpose, when your job is to explain x1, x2, x3's impact on y, where y is the switching behavior, you use the whole data set. When your job is to predict, you break it into testing and training. Testing 30% of data set, training 70% of data set. You can change it also, you can do something called set.seed, which we will discuss in a different class probably, how to set it so that you can produce reproducible research, so that the number of data set that you create, the random numbers that you generate when you are doing sampling and random numbers that I generate remains same. So, all of these things can be done and I get this result. So, we will continue on this in the next video, and where we will discuss about choice based conjoint. Thank you very much.